All right. All right, everyone. Hi. Hi, everyone. Can everyone hear me fine on Zoom? Yeah. Okay. Great. Okay. 1 second. Atika, did you open the chat box or did I open it? It's yours. Okay. All right. It's good that I have that so I can get an idea. Okay. All right. I have these headphones in my head just because I need to see if anyone is talking anything on Zoom. So not because I'm listening to something else. Any comments, feedbacks from the last lab? Do you have any issues? Did you try it out? Try the last lab? No. If you have not had the chance to try the previous lab, please try it. It's very important because it kind of shows you the basic concepts of how to do data processing. Let's take it out. Data processing using Python. And today's lab would be all about feature engineering. So what we did last time was we discussed what is data, how to work with data when it comes to AI algorithms, and then the lab will also link to that. Today, we will actually try to focus on how to go forward and do feature engineering on data sets. So if you have not had the time, go through the lab requirements, the details of how to run the lab, do it at your own time. It's very easy. And the thing is, these labs and assignments, which will come later in a few weeks, not in a few weeks, a few days actually, they are linked. So if you miss any one of them, um, it could have problems for you. I mean, just to make sure that all of us are on the same page. The first assignment which we will get will also be around data. So it's good if you have done some lab works around data. Any problems or any concepts which you need to, you have any questions from the last lecture? No. All right. Fine. You have that flask, and I thought that was your hand. Okay. So, yeah. The question is, if we are dealing with images and input data, so does data cleansing applied on it? If yes, how? Yeah, of course. I mean, data cleansing is everything. So the last time we taught or discussed that data cleansing, we did data cleansing on text files, right? Text data. But imagine the same simple example would be you're making an algorithm which detects either a dog or a cat, and you're supposed to clean that data set. And since you have accumulated that data set from your own personal information, from your own cats or dogs images, so you cleaning the data set would be looking at the pictures and seeing if the pictures had picture of some other animal, or picture had, if the album had a picture of an object which did not belong in the data set. So you need to make sure you should have like a clean data set which you can use for your algorithms. All right. So so let's talk about what feature engineering is. So what you do in feature engineering is that you take a look at your existing data and you try to understand the attributes which the data might contain. So when you look at a cat and you immediately know the cat has 2 eyes, it has 2 ears, it has a tail, it has like fur on the cat. These are unique attributes or features of the cat which identify the cat from other animals. Within the cat, you will have more features which will uniquely distinguish it from other cats. But everything has some features and attributes which make them stand out, for example, right? The color of the shirt I'm wearing, the color of the pants I'm wearing, same goes for you. Every one of us have different features. So we're all humans, so we belong in the same category of class. but individually, we have things which make us more different than others. So if we were doing feature engineering on a group of species, then for us, for that group of species, the features would be, first of all, on a very high level, distinguishing if it's a human or an animal. And for a human or an animal, it's very easy, like 2 legs, 4 legs, walking on the legs or standing on the legs, eating raw meat, cooked meat, few features which we can identify. There's no universal guideline on how you identify those features. There's something which comes from your intuition. So that's one. And if you go a bit down from the macro level, you go down to a micro level, and you now need to identify within humans, you need to identify which area they come from. So then you can distinguish between Europeans, Asians, Africans, Americans, well, they're the same. But yeah, so you can kind of differentiate different regions where they're coming from. And then if you want to go more micro down, then like if you want to focus on Europe, then inside Europe, you'll focus on like language is the most important part. Then the way people dress, the way people live. So these are features which you can think about of different set of people. And when you apply those features, you make them unique. So that's exactly what we do in machine learning too. What we do in machine learning is we take a look at the data and take a look at this image, for example. This is like a scrambled data set of random objects. And when you apply feature engineering on them, you kind of make some value from the data. You kind of understand the context on why that data was. You could also say you kind of create a storyline around that data point. So to give you another example, if we were to use feature engineering on character recognition algorithm, the way we would try to identify the features would be, say, by character, I mean like it should be A, B, C, D, any kind of character, right? And if you're making an algorithm which identifies which character is on an image, the features you would identify, the pre-step for identifying features for character recognition is that you have to identify the pixels. Are they going straight? Are they going horizontal? Are they taking a curve? So if they're taking a curve, it's probably a B or a C or a D or a E, for example. If it's a straight one, it's either an I, it's an L. So that those kind of features you would identify while building a data set for a character recognition algorithm. And it's a very unique data set, right? This is a very closed data set. You'll only focus on those kind of features. Another important thing is the detection of the stroke. Nowadays, we do a lot of things through computers, but a lot of the characters are also written by hand. So every person has their own style of writing down an A, B, or C. So you also need to identify which style to identify when you write an A, for example. That's also kind of a feature. Number of holes inside the characters. For example, I or L doesn't really have a hole, but A and B have like a hole in them. That's also a feature. So the more features you identify and you try to give your algorithm, the better it will be for the algorithm to give you a good prediction. Another example would be speech recognition. So like if you have a data set for speech, and by speech, I mean like audio files. If you have a data set of this course, for example, and you take all you extract the audio from all the presentations which I've given, and you try to do feature engineering on them, the most common features you can identify from that data set would be the length of the sound, for example, the amount of times I have taken a pause during every sentence. If I've used only English words or I have switched to some other language during the presentation. What else? Yeah, and yeah, for example, how many times has it only been me talking and someone else been interrupted or asking questions, or we have a dialogue in the conversation? That's also a feature for the audio file. So it's like you look at the data, but then you try to identify points around it, or try to explain why this data is there, or what can be done with the data. If we take another example like spam detection. So in spam detection, the way they identify the spam, of course, it's they read through the email. They have a list of words which immediately will kind of bounce as spam. A lot of spam which are originating nowadays are regarding cryptocurrency, Bitcoin, any other kind of currency which are kind of being sent in. Hash addresses, your MAC addresses, these are also spams. IP address is also spam, consider spam. It's also the frequency of certain words. For example, a lot of people who try to send you a spam will try to focus on how you can earn a lot of money pretty quickly. So they would try to focus on the money word over and over again. A lot of spam are also regarding meeting online people, making friends, dating. They will try to focus on that part over and over again. So like they're trying to sell you very hard, aggressive selling part. That's a pattern they identify. It's also the grammatical correctness. Like one of very I don't know if you know about this, but there was one of the Offently companies, they identified a phishing spam. Someone sent them an email asking to transfer some money to a specific account, and the email seemed very genuine. Like it was, I mean, it's pretty common for the accounting department to transfer that specific amount of money. It's no problem. This is a very usual thing to do, but there was some grammatical mistake in that email, and what they identified was that the person had used Google Translate to translate from English to Norwegian. They had used someone to correct the structure of the sentence, but there was one mistake and they sent it anywhere. So the person who received it paid some more attention to what the text was, and they identified it was a spam message. So spam messages can be identified if there's like some grammatical problem. And I mean, the most common one is that most spam messages come without any email header. Like if you're sending an email, you would probably pay some attention to writing the header of the email. Even though it's very annoying, you would still do that. But people who send spams, they're sending so many spams, they don't even think about it. So yeah, spam is a very, very interesting use case, actually. So having told you like 4 areas, could you give an example about computer vision? How can we use an image analysis? I'm sure you have a few slides open as well, but I mean, in addition to the points mentioned on the slides, can you think of anything which could be a feature for images or vision? Pixels? Yeah. Pixels are actually, no, but what exactly about a pixel? Correct. Yeah, absolutely. So what you are looking at is the structure of the pixels. Now you were thinking in the right direction, but what you did was you started thinking exactly about the algorithm, and that is fine, but that should come as stage 2. This is a pre-stage for making the machine learning algorithm. So you only think about the data itself. So if you talk about a picture, for example, and you think about pixel, then the attribute or the feature you would find is actually um, the layout of the pixel. Is it straight? Is it horizontal? Is it round? So that would be, yeah. So your thinking was right, actually. Any other example? Yeah, okay. Layout of pixel. Yeah, so layout of pixels is also very similar to what you pointed out. Anything else? Have you ever seen like high quality images and low quality images? I mean, of course you have, but I mean like really low quality, which you cannot identify the person at all. That's also a very good example of using images for computer vision examples. And that's a very important one because there are cameras, there are cameras which are producing high quality images. So no problem to identify any object at all. And then there are cameras which have a really poor quality, and you have to deduce what actually you see in the image. For example, one of the companies I am working with, they make like a very cool product. They're making an algae. They grow algae inside a container, and it's not artificially grown. It's grown inside the lab. And once the growth is completed, they then take it out of the container. They they transform it into food, which is then fed to the fish. So it's more of an organic food for sea animals. They were using artificial intelligence to identify how much algae has grown. And the camera they're using right now, it works very well in light. They have very good light on taking the pictures from that camera. But when it comes to darkness, but I mean, that's like an offset, right? They didn't plan for actually shutting down the lights because they were like, lights just stay on all the time. But what if the light is off? They didn't plan for that. So then they kind of realized that they actually needed a camera which could also take pictures in the dark. But of course, the pictures in the dark is different from picture in the morning time, and that impacts the algorithm because now you had a huge data set which was only pictures in the morning time, and you had at least 20 pictures which came in the night. So your algorithm will kind of confuse because the pixels, the whole layout of the pixel has changed. The way you identify the structure of the algae has changed. So we're still struggling with that problem. It is a problem, but one solution we have, because what you want to do in AI is you want to have a consistent data set. You cannot have a changing data set. If you have a varied data set and you can't control the data set, your algorithm will become confused. So what we are trying to do is to transform the morning images and the night images into one black and white image, which is more consistent for the algorithm. So we take the morning image, which is colored data. We take the night image, which is kind of black and white, and we apply our own algorithms and we convert them into a black and white image, which is fine for the algorithm because the algorithm needs one consistent set of data, because then the pixel ratio is fine. It gets the same amount of information. So I think what I wrote down here was, yeah, edges and objects as well. Yeah, so I think it's probably what you guys also mentioned, like layout of pixels. Okay. Another thing about feature extraction is that it's the same thing we discussed earlier, but if you have a data set, a textual data set which contains address information, you have information like location, then the kind of features you can deduce would be address, city, zip code. And then, I mean, when you have time is the most easy thing to make features on, because there's so much information you can, like, if you have a time, you can bring number of the year, month, date. You can also bring information on morning time, evening time. Was it a weekday? Was it a weekend? Time is the most interesting feature set ever. And only one day, having one day information can tell you a lot about the data set. When did it happen? Like the same number of passengers we have on Router for every different day, because it's either a weekend, it's either a weekday, it's either a holiday, it's either Christmas Day. For that specific time, the data changes a lot. So when you associate, every data would have time associated with it. Every data set would have time. And when you have time, there's so many features you can associate with time. And it's just, I find it so interesting. And then the last one is numbers. How can you turn like age numbers into ranges? But I will show that with an example. But I mean, this is a very interesting example. Like you see an image, right? This image you see in front of you, this is like a car. If I were to just ask you now, can you identify any features in this image, what would come to your mind? Yeah, yeah. Car brand is a very good feature, yeah. Of course. But that's something you are assuming beforehand. This is the only picture you have. So you have to identify pictures from that image. Yeah, you raise your hand. No progress. You raise. Yeah. Yeah, correct. That's a very good feature. Yeah. Color is a very good feature, yeah. Look at the road. Yeah, yeah, okay. So it's, yeah, that's also a feature set if it's standing on the road or it's standing on a showcase inside a shop. Yeah. Hmm? Yeah, some cars have 2, some have 4. Yeah. I think, are you? Yeah, I could. Yeah, okay. Thank you for that. That is a good point. That is a good point. Yeah, I didn't think about that one actually. All right. Any other features? No, but these are very good features. Kind of identify that this is actually this kind of, it gives more information to the picture. Think about, I mean, it's very easy. Like, just think about if you're looking at an image and you're telling a person who can't see the image, a blind person, for example, how this image is, you're going to start telling them it's a Tesla car. They don't know what Tesla car is. You can try explaining them what a wheel is, to understand the concept of a wheel. And then you can explain where the steering wheel is, how many lights it has, how many windows it has. And that's how you explain it to an algorithm as well. So those are the features you identify and you write them down. So what happens is, you start with this image, right? And then I'll give you 1,000 more images, and you go through those images and you say like, all right, these 1,000 images have more or less the same features because all of them are pictures of the car. So the features you identified just now are the same features you can apply on the same data set. So so let's say you identified 5 features. 5 is more than enough. That's a lot of features. In a production level algorithm, you probably identify around 3 to 5. And if you can identify 3 to 5, that's a lot actually. So you identify 5 features, and then you train up your algorithm, and you use your features as input to the algorithm and data set as well. And then you train the algorithm. The algorithm runs, and then it will give you an output score. They say the more features you have, the better the prediction rate of the algorithm. It kind of goes up and down. It might be true, but it depends on how well you have used the cleaning on your data, how optimized your features are, and how well your algorithm is. It's a combination of many different things. And once that's done, then you put your production algorithm to production, and then you try the different new images, and the algorithm will give you an output if it's a car or not, and so on. All right. So another kind of data set, a bit complicated data set, but I mean, just to give you an example, that's like the pattern 1 and the pattern 2. These are like some mathematical equations. Well, not really mathematical equation. It's just a random set of strings. All right. And if you're given that random number of strings and you are asked to make a pattern set out of it, sorry, a feature set out of it, you could do a lot of things. Like in the first example, you could like take delta plus b plus plus, that's one feature. You could then take plus plus t plus, another feature, right? And on the other hand, you could just split it around and do it. Now you're doing it in one direction, you could do it in the other direction. It depends on you, how you see the data set. And that also means that you working on the algorithm with your kind of feature sets and your friend working on the same algorithm with the same amount of data, but having different kind of features would have a totally different output than yours. And that's why AI is a bit hard to predict and control. It's hard to explain as well, because it depends a lot on features. It depends a lot on data. The algorithm has a very small part to play over here. It's just there to put it, to use the computational power to use your data and features into it. Another way, like this was something I found very interesting, is that, yeah, you can use strings and you can generate more strings from them. You can use images and you can generate more images from them when it comes to features. But you can also take strings and you can generate binary values from them. And a lot of prediction algorithms, they kind of require you to use binary values only. So has anyone heard about this Titanic data set, which is available for free on Kaggle? You could use it? No, okay. So if you open up Kaggle, or if you open up, if you just search for machine learning examples, the most common data set which is used online is a Titanic data set. It's a collection of a huge number of all people who took Titanic. Does everyone know what Titanic is? Yeah, okay. So for those who don't, it's a very cool film. You should watch it. But what happened is that the people who took, they have information of all the people who took Titanic and the people who died and the people who survived. And they kind of mapped it out, and they had all the information on their age. They even had information on how much price they paid. So based on the price of the ticket, they were able to identify if they were rich people or poor people. And of course, they had information on which deck they were at. And the most expensive or decks were on the top floor. I mean, they made very interesting observation around it. And I think we should discuss that data set in the class. But the algorithm they use, so they had information about their age, they had information about their gender, they had information about were they old, were they young. So instead of using exactly that data set, they converted into binary values. So for gender, they had either 1 or 0 for male or female. For young or old, again, they had 1 or 0, and they converted everything into binary values. That was the feature set they use for data. And some algorithms require you to do that, convert all of your data into binary values or use those features and then use it in the algorithm. So this last example is that conversion of your string into a vector-based value, which you can then use inside your data. But we'll talk about the Titanic data. But I think Theo and Atka have prepared this Titanic data set, right? Yeah, okay, cool. Have you tried Quora? Yeah, it used to be very famous. I'm not sure how famous it is now, but this is more of a question and answer thing, right? You ask a question and people can reply to those questions. And let's say you're making an algorithm which identifies good. You want to rank different answers. Well, you're not making an algorithm, but let's say that you're making a data set of all the answers which were ever put into Quora, and you're extracting all those answers. Now, when you look at an answer, you have to what you want to identify is using machine learning. You want to identify which answer was the best answer amongst the 5 answers, and how would you do that? Because I mean, if you go to a question and you browse, you can easily see which answer was the best one. There are many features or attributes which identify how a question was, how an answer was a good answer. And they are like, if that answer received the most amount of points, that means that was the best answer. If that was approved by the admin as the best answer, that was also a good answer. Upvotes, downvotes, and you would also like to see that person who kind of, especially in Quora, you also want to see that person who answered the question, how much experience the person had in that specific field. So that could also be a feature set for you. So again, like as much information you can extract from the data set would become like a feature for you. So what happens when you are done with the feature engineering? What happens is that, so that's how the image starts. On the left-hand side, you have your data sources. You take your data sources, that's raw data. You do some data cleansing on them. Once data cleansing is done, you then apply some feature engineering on it, which is also this, like the clean and transform part. And then you apply the model on it. And once the model is done, you can either use it to create insights or you put into production. This is a very common high-level diagram of how a machine learning model is made. This is how you will also make it. Any questions or any confusions? Yeah. Well, features are when you apply feature engineering, you kind of get features. So features are exactly the same as attributes. Yep. So it's the same exercise we did on the car example, right? When you were looking at the car image and you were identifying different attributes. So I might have made a mistake by using attributes and features interchangeably, but they're the same thing. So yeah, that's actually a very good question to ask. Could you elaborate on that question? Like, what really is the confusion here? Like, how would you? No, you're right. You're right, because the model, there are models which if you give them the data set, they will generate features for your data. But there's only a specific amount of features. Like, you know, AI itself is very, it's not being able to, it's not fully AI. So it doesn't really generate all the features you need. So what developers do is that you can use a machine learning model. You give it, you give you feed the data to the model, and the model kind of generates the features for you. But then you have to have the manual process where you also add your features to the data set. So there's always manual work involved in it. But yes, models have increased in performance over the years. Yep, I am looking at that. So the question is, should we use the image processing algorithms to extract the features, or there are other built-in models to do that? It's very similar to what you were asking. And the answer is yes, you can use, there are algorithms which already help you with this one. But again, it's the same problem, like, yeah, you would have to do it on. The remaining ones you have to do on your own. Since it's a break, let's take a 15 minutes break and come back at 3:30.